Well, welcome again to everybody. This is an important topic, so I'm glad you're here with me to learn about one of the biggest risks that I feel exists in the IBM security space, and that is access to the system and the database through common desktop tools like FTP and ODBC, DDM, and RExec. Many of you know me, I'm sure, but if you don't, my name is Robin Tatam. I'm the Director of Security Technologies over here at Help Systems. I'm also one of the IBM champions for 2020 and a subject matter expert for Common. So do a lot of speaking engagements, evangelizing security on the platform, explaining how to use the operating system tools that are deeply integrated within the operating system, as well as, of course, speaking about the benefits of the help systems tools and services that we offer as well. Something I'm sure many of you know, but is important to understand, is that the I that we commonly use within the IBM I name, the I series name, stands for integrated. And it means that everything within the operating system has been built together and integrated, so it's all fully tested and cooperative and works really, really well. That's part of the reason the system is so robust. What's also important to understand, however, is that in this instance, especially in terms of the database, any user who has knowledge of credentials to the system can access the information, the data, through any interface that is supported on the box. So there's no distinguishing between the different ways to connect. You either have permission to come in or you don't. If you've been around the box for any period of time, you're probably familiar with this term green screen. The official name is more the 5250 interface, but the traditional way of working with IBM I applications. Now, back in the day when we built these types of applications, and I was a developer for many years and built lots of these types of programs and applications, we didn't really have to put too much effort into building security into the applications, because in many instances we would put the user into a menuing system and that would control or corral the users into only being able to perform the functions we expect. Now, these green screen interfaces basically pass through a layer of the operating system known as object level security. This is where at a library and object level we can indicate the resource access or the authority that a user has to the different application components, whether it's a file that contains data or a program that performs a particular function. In order to help us with that object level security configuration, IBM created 4 authority shortcuts. You've probably heard these terms before. They're very, very common, but in many instances, we don't necessarily truly understand how much they allow a user to perform. So as I mentioned, there's 4 templates. Starting at the bottom, the exclude template is a permission to do nothing. It's kind of strange that you grant somebody the permission to do something, or to do nothing, I should say, but that really comes down to the fact that we have a concept in IBM I called star public, and I'll talk more about that in just a moment. Stepping up from there, we have use, then change, and finally all permission. And as you can see from the bars here, they allow different amounts of activity against that particular object. Most of us are concerned with the data within the file. And really the big differentiator there is the step up from star use to star change, where we transition from being able to see data to being able to modify and delete it. The all permission and the addition of the maintain capability pertains to the actual file itself in this instance. So you can delete the file, not just the records inside it. But let's face it, if you can delete all the records from the file, does it really matter that you can delete the file itself? There's nothing left in it. So for me, it's really the understanding that even star use allows for a data breach, and star change allows for a data breach plus the corruption of data. So we want to be very cognizant about how we use those permissions. In fact, when we look at it in a negative context, I give some basic descriptions here so you understand that the only true safe permission is star exclude. Of course, we're going to have legitimate users that have to be able to access the database. So that's where some of the skill comes in. How do we accomplish that without allowing the user to leverage the types of permissions that allow them to steal the data or change or corrupt the data? One of my responsibilities at Health Systems is to publish the State of IBM security study. And what we know from that is that most application libraries are not overly secured. Now, here we see the public permissions to the libraries. And if you're not familiar with the concept of a library, it's simply an object container. Everything lives inside a library, be it a file or an application program. The authorization list designation here is arguably a margin of error. The reason for that is an authorization list allows the designation of the desired permission somewhere else. And we don't know how that something else is configured. So it could be wide open, it could be completely locked down. So let's describe it in this context as a margin of error. We know that usually about 10 or maybe not even 10% of the libraries on a system are set to this highly desired state of public exclude. Think of public exclude as the principle of least privilege. At this stage, yes, you have credentials, but we're not really sure what you're supposed to be doing on the box. So we're going to start out with you having no permission at all. And if there's only 10% that have that, then that means almost 90% of the application libraries are open to anybody who has a user ID and password. And that's extremely concerning when we understand that the library is usually the first line of defense. The reason it's the first line of defense, not only because it's checked first, but because there's a lot less libraries to deal with. And I don't know about you, but when I'm securing things and I have the choice of securing 5 libraries or securing 5,000 objects inside those libraries, I'm going to work on the libraries. It's easier to manage. It is going to be a simpler task to accomplish. But what this is telling us, and this is based on a review throughout a year of several hundred systems. So this is very representative of what I see day in and day out on all IBM servers, is that once the user connects to the system, the application environment is wide open. The libraries are permissive and the objects also are permissive. And that's because we've leveraged menus and command line restrictions in order to control user access. In 2020, we analyzed over 250,000 user profiles, and that's a lot of users. Now, what we found from that is that on each system, there's an average of 159 profiles that have what we call all object special authority. And all object is a permission that says you can access any object in any library, even if they are objects created by someone else, perhaps a software vendor, or even IBM as part of the operating system. You have carte blanche to do whatever you want to every object. So what we understand then with this traditional interface is that object level security is largely not present. So we have to come up with some compensating controls. You know, you may have heard that term, may not be overly familiar exactly how or what compensating controls might exist in IBM I, but you're probably already using a lot of them. Application menus, application security, and restrictions over that command line that shows up at the bottom of a green screen. That, in a traditional sense, is how we typically will control our user community. It works. It squeezes out and ensures that the users are only doing what they need to do. The fact that object level security is really not present, not configured, is not overly important. Where we get into trouble, however, is when we recognize that dumb terminals or green screens are not the only way now that we connect into the system. While we may be using green screen emulators on our PC, there are other interfaces that are potentially going to allow us to connect into the system. These were created by IBM at our request. So they're not backdoors into the system. They're simply alternate ways of accessing the server, accessing the data in the files. Examples of this include FTP and ODBC. Now, these are legitimate interfaces when used legitimately. So if we have a need to access files within a tool like Microsoft Access or Excel, we have this ability where we can now work with this valuable business data and hopefully quickly create really good decisions for our business. We can also potentially upload data back in, so we can import data. Again, an important aspect if we're sharing information with trading partners. The problem is that this can potentially lead to issues, not only with visibility to the user or the potential corruption of data by mistyping something in something as simple as a spreadsheet, but we also now have the possibility that that data may leave the organization. And there is a whole entire alternate internet where there is a marketplace for your data. Now, if you think to yourself, yeah, but my data is pretty proprietary, it's not worth anything on the market. It's not bank information, it's not credentials, it's not credit card information. You have to recognize that in order for a criminal to determine that your data does have limited value, it's always valuable to somebody, then you've already been breached. You've already exposed that data. And in many instances, under regulatory mandates, you still have to disclose it. You can't disclose it with a footnote that it doesn't matter because the data is only valuable to you. So the compensating control concept is necessary on both sides, not only with the green screen, but also with the non-traditional interfaces as well. The types of compensating controls here tend to be focused on exit programs and also application administration. Now, application administration is something that is included within Access Client Solutions. It gives you a small amount of control over the types of PC connection activity that you can perform or that your users can perform. It tends to be beneficial in certain aspects, but it's not very granular. It's not going to let you decide that you can FTP this file in this library and then log that action to a file. It's a little bit more of a sledgehammer approach to controlling that user access, but it has a part to play in this discussion. What I want to share with you, of course, is that we always encourage object level security. Just because you're using compensating controls doesn't negate the benefit of object level security. They're not mutually exclusive facilities. You should take advantage of this very robust, secure layer within the operating system. So let's have all of these firing on all cylinders. Now, you could be sitting back in your chair right now, smiling with your hands behind your head and thinking to yourself, thank goodness we did object level security, because if we have that layer implemented and every one of those interfaces always passes through object level security, which it does, then I'm alleviated from the requirement to have those compensating controls. But I want you to think for a moment. First of all, if you believe that you have object level security, I want to just bring to your attention the idea that I often hear people tell me they have object level security, but in many instances, that infrastructure is not as secure as they think it is. They've done a best effort, or they have implemented it in the past and things have changed, or they missed that there was a different way for a user to access the information through adoption or other things. So yes, we encourage object level security, but don't ever think that it's a perfect model. It's so rare that I come across somebody who has implemented what ultimately could be argued as perfect object level security. Let's assume for a moment you're that unicorn, right? A unicorn is something that sounds really cool, but nobody's ever seen one. Object level security is that unicorn. And if you think you have that, what you've got to understand is that if you are granting authority to your users for the business applications, that those authorities are going to carry on through all user interfaces. That's because IBMI can't differentiate between the different ways to access the system. So if I open the door for 5250 access, I've inadvertently also opened the door to FTP access. Likewise, if I try to close the ODBC door, I've also closed the green screen door, and perhaps the application now doesn't function. So I've got this trade-off where I can't differentiate, or I can't segment those different access methods. We also know that even if you turn all of the auditing functionality on that is included within IBMI, the amount of information you're going to glean about those network connections is very, very limited. You may at best see that a user accessed a file, but you won't see the SQL statement they ran to extract data. You won't see the FTP directive that says not only are they looking at the data, but they've downloaded a copy to the local network as well. And arguably one of the most important considerations is if you have leveraged, as we encourage, good command line restrictions to everybody but administrators, there are several interfaces that you can bring up on a PC that still allow a user to run commands, right? So we introduced this idea of an exit point. I mentioned that as a compensating control, and there's a related term, which is exit program, and they're often used interchangeably, and there's some confusion between what they really are. So here's really an explanation that hopefully will clear that up. The operating system has lots and lots of different exit points scattered throughout the operating system. And the purpose of an exit point is simply to interrupt an existing process or function to allow or enable a custom function to be invoked. There's about 30 of these exit points that are relevant to users who are connecting from the network, perhaps accessing the database or running commands against the system. The exit point itself really does nothing except invoke the exit program. So the exit program itself is what does the work, and the exit program is something that you have to write or buy. It is not part of the OS. The exit program is going to be invoked automatically anytime an action is performed by a user that is related to that particular exit point. Let's clarify a little bit further. There's two types of exit point, a pre-process exit point and a post-process. If we take the one on the right-hand side, first of all, a post-process exit point, a user makes a request on the system. The system then responds to that request, potentially performing the task that was asked of it. After that task has been performed, there is an exit point potentially that sees an exit program exists, and it will now invoke it. A good example of this is the creation of a user profile. When a user says create user profile, assuming that they have the necessary authority as a security administrator, the system will create that profile. After which, the create user profile exit point will look and see if an exit program has been registered. And if so, it will now invoke it. Perhaps that program will create a work library for the user or enroll them in your application. If no exit program is registered, then the process just ends and everything is complete. Let's compare and contrast that to the pre-process exit point on the left-hand side. This is where the user makes a request of the system, but before the system responds, the exit point is checked, and if an exit program exists, the exit program will be invoked. If there is no exit program registered, then the system responds just as it would have normally. If the exit program is invoked, the difference now is that because it's happening before the system performs its response, the exit program can say, no, I don't like the look of this user request, and I want to deny it. So it enables the ability to shut down a request that is not desired. We're going to focus our conversation on the pre-process exit points because the network services are all pre-process exit points. So we get a really unique benefit here that we can start controlling what users do on our system, even if the system normally would allow them to perform those tasks. As I mentioned, an exit program has to be written by you or purchased, but whoever wrote it, whether commercially or homegrown, you really want that exit program to do two important things. Number one, you want to audit the connection. You want to make sure that you're logging the important transaction so that there is a record of it. This is a base requirement for virtually every regulatory mandate on the books. Then we want to provide access control. Access control is going to allow you to set rules around what users should be able to perform these tasks. Think of it like a firewall now. You're allowing some users through, some business transactions through, but others are going to be rejected and kept out. The exit program has that ability to return a pass-fail indicator back to the exit point, which will then shut the user down or allow the transaction to continue on its journey. It still has to go through object level security, but we're going to, in essence, pre-validate that that request is reasonable. All right. Now, because it still has to go through object level security, the exit program doesn't have the final say. It simply says that the pre-check is okay with the concept of what the user is asking to do. Right? So back to here, we now can see that because object level security in most instances is completely transparent, it is non-existent, the importance of exit programs is absolutely critical. Now, with that being said, I'm going to share a quick poll with you, and I'd like to get some feedback about how you or your organization has secured your applications and your data. I've set this up so you can give multiple answers, and starting with object level security, then the all common menus and command line restrictions, whether you have exit programs, or maybe you've done something else that I haven't listed here. Obviously, there's a finite amount of space that I have. Or, yeah, let's be honest, I don't really know how the application is secured. Right? I'll give you just a moment to answer that. Looks like right now, 100% of you are saying menus and command line restrictions, which is not a surprise. I see it all the time. And don't get me wrong, I'm not undermining the value of that because we still encourage it. It is still 100% effective in the green screen traditional interface world. What we have to understand, though, is if the user is coming through one of these non-traditional interfaces, they don't see the menu. And in some instances, even the command line restriction is not going to impose anything. All right, I'll give you just another quick minute to answer that, and then we'll shut that down. I'm impressed. 60% of you are saying you have object level security. The realist in me would push back a little bit and say that I would be very surprised if the percentage of people is as high as 60%. It is so rare that I see really good object level security that it's usually about 5 to 10% of shops that actually have implemented something like that. So with all due respect, what I want you to think about when you have object level security is how robust is it? Have you gone down to the object level? Are you working at the library level, which is okay? And are you accommodating the idea that even though public permissions may be rejected, every user belongs to a group, or every user is an owner of those application objects? And that is a common way that object level security is undermined. All right, folks, I'm going to close that down. I appreciate that feedback. Let me just share those responses with you here so you can kind of see how people are doing. And absolutely, that's, I think, a pretty representative view. Other than the object level security is very, very high. And so we want to make sure that there isn't an expectation of object level security in unbeknownst to the group that is easily bypassed. All right. So let's go back here. We understand how important exit programs are. 24% of you have said you are using some level of exit programs, but what we see overall is that the vast majority of users still are not leveraging this component of their IBM I security. Now, bear in mind, this was introduced in 1990, I think 94, 95 as a capability, meaning it's been around for a quarter of a century now, but only 8% of systems we looked at had full exit program coverage in place. It was a little bit higher if we looked for those that had 1 or 2 exit programs out of the 30, which is usually indicative that somebody's kind of written a few of their own. They're not covering all the interfaces, but they've at least taken a stab at it. The problem really stems down to education. People are not really aware that this capability either exists or they believe that their menus and their command line restrictions are sufficient and that they don't need exit programs. And neither one of those really are going to save you at the end of the day. And the good news is here, you don't have to write your own. One of the first applications that the Powertech group created was a tool called PowerLock, and it was a fantastic tool that was based on exit programs. Fast forward many years later, the Powertech group has been acquired by Help Systems, one of the first acquisitions we did, and this tool has evolved through generations and generations. It's now called Exit Point Manager, so that it aligns a little bit more closely with the fact that it is controlling access via these exit points, right? Used to be called Network Security at one point as well. The rename to Exit Point Manager happened about a year ago, because when people hear the term network security, they think PC network, and we're focused here on IBM I. So I want to share with you just a way that this can be exploited and controlled. Here we see a profile in an IBM I environment. Up at the top, we see a user on our system called Paul. Now, Paul's a little bit of a troublemaker. Unfortunately, for whatever reason, Paul is a security officer class user. Now, word of caution, user class itself isn't overly meaningful, certainly not as meaningful as many people and auditors think it is. What's more important is that we page down and we look at Paul's special authorities. And what we can see here is that the special authorities are actually in line with the user class. In many instances, it's a mismatch. And that's why we want to focus on the special authorities. Here we see the user has all 8 special authorities, administrative privileges, if you will. The most important one, clear at the top, star all object. I talked about that a little bit earlier. You have an average of 159 of them on your system. Now, for Paul to be able to modify data is basically a given. Assuming that he has command line permission on the green screen, he can invoke a tool like DFU, Data File Utility. There's a number of others. You could write an RPG program. You could do a query with the output of another file. There's lots of ways to manipulate data. But when that data comes up and we see that there's sensitive information, the operating system thinks that it is fair game. In this case on the right, we see that it's a file called payroll. This file has, no surprise, payroll information in it. I don't know why in the IBM I world we have a penchant for creating files and libraries that are very clear on what they're used for, which I guess as a programmer is helpful in somebody who's querying the database legitimately, but it also means this information is really easy to find. It's one of the quickest ways that we compromise a system is looking for directories and libraries that are named based on, critical information. In this case, Karaoke has a salary of $73,000 a year, but without too much difficulty, we can inflate that up to $83,000 a year, and that's the end of it. Carrie's now going to get a nice bonus on her paycheck at the next pay period. Now, green screens, like I said, can be controlled relatively easily, but what about the PC? Here we see a 5250 emulation session that has a button on the toolbar that says data transfer from IBM I. If we bring that data transfer up, we see that by connecting to system URL and grabbing the file payroll in library payroll, we have the option of designating that we want it to go to a file, meaning it's just downloading a copy. In this instance, we're going to send it to the display. Of course, remember, Paul is a all object user. He's a security officer in essence on the system, and the operating system thinks that what Paul is asking to do is perfectly legitimate. But even as a user of the payroll application, perhaps he probably should not be DFUing the file, granted, but he certainly shouldn't be downloading it in this instance. So what we've been able to do is indicate to the system that despite the all object, we want the exit program to determine that user Paul C is not an authorized user of the file transfer function. And what we get here is an error being returned, and you note the text that says this function was rejected by user exit program, meaning that the request was issued to the system and the exit program was there, it was invoked, the rules were checked, Paul C was not an authorized user of this request, and the exit program said, shut him down. Now there's another file within this library called pay new. So just as an example, I'm going to run that same transfer. And in this instance, I get the data being displayed. And this is probably what you're more used to seeing. So what we've exhibited is that there is possibility, despite this user's express permission to the file, that we can actually control which files are opened and also then which files are uploaded back. There is potential that a user could change data in a spreadsheet. They could upload it back in the same way the DFU does it. So even without command line permission, pulling the data into a notepad document or a spreadsheet, manipulating the data at that level, and then sending it back to the host leaves really no audit trail. All of a sudden, the data is different. And let's hope that that data is structured correctly, because if somebody alters the structure if they do it in Notepad and they delete a line or delete a character out of the line that shifts everything over. When you upload that data back, it's completely corrupted your database. All right, so those are Windows tools. What about some basic FTP function? You all have DOS prompts on your PC. If you bring that up, which you probably try not to do too often, it is extremely easy to use FTP. In this case, we're again connecting up at the top to system URL. We're entering the credentials. That's always a given. We're putting our user ID and password in, but as a legitimate user of even the basic application, I'm going to have those credentials. I can also tell you from the State of Security study that far too many shops don't take their credential management seriously. There are at least 3 or 4 systems every year that I encounter that have a password length of 1. Right? We have an expectation that the firewall is going to save us, so we don't worry too much about user IDs and passwords on an internal system. But if somebody gets into your firewall or somebody's on your network that is up to no good, they're going to discover those user credentials quite easily. Right? Now, Paul goes ahead and he logs into the system, but he doesn't know that much about FTP. So the first thing that Paul does is issue a help directive. The help directive will then list all of the available FTP commands. And what we see in that list is one called remote help. Bear in mind that people that are actually trying to exploit systems know this environment extremely well, but maybe they don't know IBM. You're banking on the fact that this system is not as prevalent as Windows, and therefore hackers don't know much about it. But if you look online, there is a DEF CON session exactly about these types of challenges, how to actually exploit these types of connections. So this information is visible, but the remote help makes it even easier. As that scrolls up in our DOS window, the first thing we see from the remote help is a number of commands that we can run that will coordinate or cooperate with the system. Down further, we get information about the name formats. Now, on IBM, we support 2 name formats. One is the native name, which is the library/file. The other one is more of an integrated file system or traditional naming, which is /qsys.live/library, etc. Right? And it spells this out for us. So if I don't know that much about IBM, by issuing a remote help, it's educating me on the naming convention that I need to use, as well as some of the file systems that are available. The bottom arrow there is telling me that there is a root file system. There is a QOpenSys file system. And when I use this format, there is then additional information that's provided about how we store those documents, where they live, what convention those names are in, that even if I am not an IBM person, I know how to locate things. So let's see what we can do with this. In this instance, what we see is that Paul issues a get statement, which is telling the PC that it needs to get the information from the server, and it wants the file called pay new. Now, if you remember, that was the one that popped up in the window and showed the data. So unsurprisingly, the file transfer completed successfully. That data is now on the workstation. However, if we issued that same request against the original payroll file in library payroll, we see that the request was rejected. And that's because, again, the exit point in this instance for the FTP server has seen that an exit program exists, it has invoked it, and the exit program has flagged that user as being somebody who is not permitted to use an FTP transfer. Another tool I'm sure a lot of you are using in various iterations is Navigator. Navigator has a very handy databases section that allows you to work with libraries and database objects. Now, the terminology here is a little bit more Windows oriented or PC oriented. Instead of a file, it's called a table. Instead of a library, it's called a schema, okay? But the concept is exactly the same despite the different names. So we still have access to the information. We don't need a command line to kind of navigate around here. We're going straight to the database function using the server actually simply as a database server. When I click on tables, I see a list of tables in my current schema or library. This is the payroll library. And we see both pay new and we see payroll again easily. We don't need to know the name. We can browse around. So when we're using Navigator, it makes our life a lot easier. However, even though we're using Navigator, we're still going to pass through the connection. In the case of Navigator, it's actually using an ODBC, now JDBC connection in order to send SQL requests to the host. Those SQL requests can potentially change or corrupt or delete the data, but it can also select the data and grab it. But in this instance, again, Paul C is not somebody we want to have performing this task, and the user has been rejected from this particular function. All right, how about Microsoft Access? I know a lot of you are using this, Excel. When we are using Excel, or even Access for that matter, we have the ability to make a connection to outside databases. By selecting Microsoft Query, we can make an ODBC or JDBC connection in. When we're asked for a data source, we can see whatever is out there. Now, there is an existing data source here for system URL. It's a very simple configuration. You basically point at the IP address and it will determine that that is a valid database source for us. When we select that data source option, it is going to ask us to authenticate. So here, we're being asked to give credentials. Again, I know that that is in theory a hurdle, but you've got a lot of users that know IDs, and you also have very weak password and profile management as a general statement. And so guessing or gleaning user IDs and passwords is not as difficult as you might think it should be. Once we enter those credentials, what we see is a list of fields here under the pay new file. So pay new, when we click on that, has an employee field, a social security number field, the salary and the department. We saw examples of that data displayed on our screen. But if we click on the payroll file, that's the one that we flagged as being more sensitive. We get a blank in the columns. And that's because, again, the exit program is not allowing the return of this information. It is blocking it from the user, okay? We do get an error then when we try to run that transfer that it was being rejected by the exit program. So again, think of the exit program as the traffic cop. The exit point in the operating system is provided by IBM and it is calling that exit program, but it's the exit program itself that's actually doing this verification. Exit Point Manager is part of an overall security portfolio. So there's a lot of different moving parts and pieces here that you can pick and choose from depending on whether you're trying to protect from viruses or do multi-factor authentication or even database encryption. So lots of different capabilities here, but we're focused on Exit Point Manager, which is part of the perimeter access control function. This tool can oversee more than 30 different exit points pertaining to FTP, ODBC, DDM, RExec, all of these interfaces that IBM has given us exit points for can now be controlled through a rules-based engine. That's the big benefit here. We don't have to write any application code. And in this rules engine, we can indicate whether we want a transaction to be logged, whether we want to see any type of access control. Obviously, I'm a big fan of access control. I've been limiting Paul C all morning here, but it's really, really important that you allow the users and the processes that are approved and part of the business function, perhaps even logging them, but allowing them to continue. But making sure that the balance of users and the other processes that might come through to your system that have no business merit at all are controlled, alerted, and logged. We can specify rules that are central to a number of different servers or partitions. So if you have a slightly more scalable environment, the rules can be designated across those. Again, we're looking to allow business transactions and reject the unapproved activities. Now, a big part of the exit program is not only access control, but it's also being able to report and have visibility on what is coming through these exit points. So within the application, there is a reports menu that we can go to. There are a number of different intrusion detection reports that we can run. I'm going to focus on the user report menu. I'm going to designate that I'm interested in my user's action. Paul C is a problem child for me here, and I want to know what he's up to. Why is he being rejected all these times? I designate my time and date delimiters. I indicate the level of detail that I want to see, and I indicate the type of output that I want to generate. I'm going to do a spool file here just so I can show it to you, but I also have the option of sending it to a DB2 file or a table that I can then query or download, and I can also send it out to the integrated file system as a CSV. That's a great way of then just pulling it open in Excel and doing your analysis there, your forensics. When this report comes back, it shows that Paul C has been doing some different things. Now, there are, of course, a lot of transactions that IBMI runs throughout the day. For most of us, we're using these services legitimately, and we're running a lot of traffic through them. So while we might have requested in this instance to see all traffic, we're really probably only primarily interested in rejection traffic, because rejection shouldn't happen. It means you've overlooked somebody when you set the rules up, or somebody's doing something they shouldn't be doing, neither of which would be a normal scenario. So looking at just the rejected transactions is a great way to manage that. So here we see Paul C connecting in. When we scroll down, we see that there were some other transactions. Paul C, first of all, was rejected. You see the select splat from payroll. That's the file we didn't want Paul C from looking at. But the second transaction was allowed. This is where he did the select stat from pay new. Okay, so we're grabbing the information here in order to see that data. So lots of different things. I didn't highlight it, but down towards the bottom, you see some file server activity. This is where a connection is happening into the IFS. If your users are mapping drives to the IFS, it's such a high risk activity from the standpoint of allowing viruses to inject themselves into the IFS. Yes, folks, you can get a virus in IBMI. Here we see Paul again is moving around the system. He went into /home, which is okay, and maybe it's not something of concern. Okay, so lots of different services. All of them can be monitored. You set rules so you suppress the noise. If it's a normal business application like HA, you probably don't need to see it on the report. So you indicate all the things that are approved and not of interest, and then your report will only show the exceptions to that. I've inserted this here because I was recently working on a proof of concept, and we were doing some live reporting to show the customer how this function would work. And he ran a report, and in the process had some very interesting transactions showing up. Now I've redacted it here for privacy purposes, but what he discovered at that exact moment was somebody was actually trying to connect in to his FTP server. They were trying to sign into that box. Now, of course, there was a firewall here, just like you guys have, but somebody had made their way through. They had compromised his network, and now they had discovered an IP address that was responding, and they were trying to discover a user ID. Now, this is just one page. There was actually, I think, 17 pages of this by the time we saw it. And it was looking for user IDs like web and root and anonymous. And those are not common IBMI profile names. So it was pretty obvious that there were things happening here, but they didn't know the password. That was the good part. But the fact that it was flagging it and rejecting it was really important. Now, the operating system, to be fair, was the one saying you don't know the password, but it was showing up on this report, and we were able to uncover it. And when they did a trace back on the IP address, it was actually determined to be coming from Southeast Asia. So it was well outside of the normal network of this particular organization. So really exciting. Obviously, they were sold on the concept of exit programs, and it was a done deal. Now, if that wasn't enough, Exit Point Manager is fully integrated with our SIM agent for IBMI. So if you want to do some real-time analytics, alerting, messaging, you can use SIM agent alongside Exit Point Manager. And not only will it see the Exit Point Manager events, it'll see a whole bunch of other things as well, like system value changes, user profile changes, anything, in other words, that the OS can log into the IBM Security Audit Journal, SIM agent can find in real time and then escalate that into some type of ingestion for a tool like a SIM. Now, if you're not familiar with the term SIEM, it's Security Information and Event Manager. It's typically a non-IBMI solution. Names that you may hear are QRadar, Splunk, ArcSight, LogRhythm, and there's hundreds of others. We actually have a SIEM of our own. It is not locked only to IBMI. It actually handles all of this across the enterprise, but the SIEM agent is the glue that binds whichever SIEM you're interested in back to the IBMI so that they are speaking the same language. If you don't have a SIEM, you don't want a SIEM, then you can also send those alerts to a message queue, or you can send them out to an IFS stream file. So there are other options alongside the SIEM approach, but a fantastic way to know in real time when important events are happening on your system that you should be apprised of. In addition to that, we also have an alternate user interface. I showed you a couple of green screens there, but many customers are now using the Help Systems Insight experience. This is a browser-based tool. It requires no client on the workstation, but it allows us to not only work with our products, deploying them, managing the license keys, but it's a way to work with the exit point manager rules. It's still listed here as network security. I have a slightly older screen print here, but what we see here is that the dashboarding function is available. This is reporting to me that there were 2 transactions that came through DDM that were permitted. We also see that there were some SQL activities that were rejected. That was Paul making his requests of the system. So quickly we can see that there are some red activities that we need to be interested in. We may be less concerned with the green unless the volume has suddenly become extremely high in comparison to normal activity, but the red is probably what I'm most interested in. So I can manipulate, I can see the activities on the system. Here we can pull up the spool file that we were looking at a moment ago. We can see the transactions. You see the select splat on about the 4th line down on the right that is pulling from the payroll here. I can go ahead and highlight some of these for you. Over here, we've got payroll being selected. We've got payroll again here. This was allowed, and different field selections. So a bunch of different things. These are all visible now in a way that previously was completely transparent. Now there's data here that's being included you're probably not interested in. I would focus my attention on those that were rejected. These are where we're trying to grab file information. So this is where we were trying to prompt on the field names and grab that information back. So a great way that we can get that visibility back. Of course, you can manipulate the rules either in the green screen or through the web UI. It's completely up to you. Whatever you're most comfortable with, that's your interface of choice. We can't really do the dashboards, of course, in the green screen. That ASCII art just doesn't work as well, but the rule configuration it's entirely up to you which interface you work with. All right, we can go from server level, so we can say, yes, you have FTP, or no, you don't, all the way down through levels of granularity down to a particular object in a library. So we can say, you can read this data, but you can't change it. So lots of different levels of granularity. Obviously, the more granular you are, the more complex your rule set will get. That's just the nature of the beast. But the beauty is you don't have to make that commitment right out of the gate. You start simple. This is a very basic function at a conceptual level. We just want to know what's happening on the system. That's how the tool is pre-configured. From there, you can then make a determination as to how deep you want to go into the rule configuration. All right, I've just machine gunned a lot of information at you, so I'm going to give you a call to action here, somewhere where you can get started. And that's by assessing your risk of a breach. Now, part of this is the recognition that most security incidences, not just data loss, but security incidences in general, happen simply because of misconfiguration at the server or host level, meaning that we just didn't set stuff up right and we made it easy for people. In many instances, they're accidental things that happen. So this is a way that you can assess the risk on your IBMI. It costs you nothing. It has no obligation associated with it. It runs typically in about 30 seconds. And not only do we let you see the results, of course, we'll also explain them to you. We'll spend about an hour with you over an online collaboration meeting, and we will explain exactly what everything means. We'll answer any questions you have about your specific situation with regards to security, and you will come out of that far more knowledgeable, most likely, than you went in, and hopefully then a good feel for what needs to be done and how to at least conceptually plan to mitigate it. All right. Now, the reason that I tell you to do this is not only because I think it's good in general, and I always recommend it, but one of the areas that it reviews is these PC connections. So our topic of discussion today is one of the tabs here, network access. It looks to see how many users have command line permission. It looks to see whether you have exit programs registered to your system exit points. So if you were wondering earlier, how do I know if I have exit programs? This is going to tell you, and it's going to tell you quickly and easily alongside a lot of other valuable information as well. Another resource that I want to point you to is the IBM State of Security study. This is something that is near and dear to my heart. It takes a fair amount of my time at the beginning of each year. It's the 17th year that we have published this. It's available for download. We also have a recorded on-demand webinar discussing the 2020 findings. So take advantage of those resources. They are out there. They are free to use alongside a number of different articles and blog postings and other resources pertaining to many things about IBM, not least of which are about security. All right, so I'm going to open it up for questions at this time. If you have a question, please feel free to use that question panel in order to send those over to me. While you're thinking about questions, I'm going to give you one additional poll here. Let me launch that. And it's a very simple one. If you're interested in a security scan, then let us know. Doesn't mean you can't do it later if you go to the website, or if you're a little nervous about committing, you can ask for more info, but it saves you signing up for it. So we'll follow up with you. If you would like more information, we can absolutely clarify what is it doing, how does it work, is it going to mess with my application, etc. All the standard questions we get asked, we can answer those for you. And we will be happy to do that for you. Again, no cost. If you choose not at this time and you would like to do it later on, just go out to the website. You can sign up for that free scan. You'll have to fill out a few boxes of information. You know how that works, right? And then we'll get that set up for you. But regardless of how you do it, there's no cost or obligation associated with that task. All right. All right, let me go to questions here, and we'll see if there is anything that you guys are wanting to know. Paul here saying we have homegrown exit programs on several of the exit points. Why would we need more exit programs? Okay, so I think what he's getting at is that there are some user-written exit programs. Again, I said earlier, you can write your own or you can purchase them. The problem if you write your own is that some of the exit points are very straightforward. Some of them are extremely complex. I wrote system application level code for over a decade, and I would not want to touch those programs. Now, the ones that are usually the easiest, like FTP, the ones that are most difficult, ODBC and JDBC. So there is an option, you can write your own, and if you want to just reject everything, if you are in a purely traditional green screen world and you want to put a literal brick wall around your system, I would encourage you to write your own. If, however, like most shops, you are using these interfaces in a business environment, then we tend to encourage the commercial approach. So as far as the question is concerned, it sounds like somebody has understood the concept of exit programs, and that's good. Somebody's deployed some exit programs. What we always question is, what is the legitimacy of those programs? First of all, just because it's an exit program doesn't mean it's a legitimate one. It could be a malicious one. So assuming that that is some legitimate programs, then we just look at the functionality that's included. So the issue tends to become then you're not covering all the doors, and the functionality of the exit program may not be very flexible. Maybe it logs it but doesn't control it, or maybe it controls it but doesn't log it. So we want to make sure that we have all of those bells and whistles, that we're not picking between them. So kudos to you guys for getting a start, but I would certainly encourage some discussion around it. All right, another question here. We have command line restrictions, so I don't quite understand the exit program requirement. Okay, so FTP, as an example, has a directive of delete file and delete lib. The delete lib can be run by a user even if you say limit capability star yes, which is a directive that says no command line activity allowed. So here we have a way that a user who potentially has permission to the database, because we weren't overly concerned because we thought command lines would take care of it, but can now delete stuff, right? So we want to be cognizant of the fact that command line, or let's call it limit capabilities, is guaranteed effective on the green screen, but questionable outside of the green screen. And so if the database access isn't enough to trip your trigger, then the command line functionality of some of these services should be. So definitely important use of exit programs. All right, well, that is the end of the questions I see. If you have one, I'll hang here just for a moment, but it looks like we're coming up on the top of the hour. I absolutely appreciate the time that you spent with me here today, learning hopefully a little bit about exit points and exit programs, and then seeing a good example of one of the best exit program solutions on the market, if of course the best, I should say, right? And how it can limit. Now, we didn't get into the granularity of how to set rules up. We'd love to show you that. We can give you a demo if you're interested, but if there's nothing else, please take away the importance of exit programs as a security discussion so that you fully understand the role that they play within your IBM I landscape. It's such a critical component to me, arguably as important as some of the common things we know, like all object authority. Those things are, encouraged to be limited, but we know it's not easy to accomplish that task. And exit programs can be deployed literally overnight and start by giving you visibility and then controlling access and reinforcing what you have done with your menuing system and your command line restrictions. So what a great synergy between those to work together. All right, guys, I'm going to quiet down now. Thanks again. Hope you guys are staying safe. Look forward to chatting with you again on a future webinar. It's been great being here, and we'll talk to you soon. Take care.